In my previous video, I mentioned that Wyoming has highlighted 5 important domains related to computer science. To highlight the importance of these 5 domains, I thought I'd take you through an example, and that example obviously is close to my heart. It's what I do for a living. I'm an astronomer. I'm interested in looking at the sky and answering questions like, how does the universe work? I suspect there's nothing particularly special about me being an astronomer that lets me relate my work to these 5 domains. I think if you really thought about it and you worked in any field of academia or even business or politics, you could probably think about what you do and relate them to these 5 domains. It could be particularly easy for me because astronomy has become a very data-rich field, and I think of myself as much as a data scientist as I do an astronomer. But I suspect that either already or very, very soon, almost any field of work will be able to relate efforts in that field to these 5 domains. So let me take you through a typical research project in what I do in my subfield of astronomy, which is cosmology, the study of the universe. So somewhere in some beautiful location like Chile or Hawaii, there's a large mountain and there's a big telescope at the top of it pointed at the sky. And that telescope over the course of a night is going to take images of the sky. Now, it doesn't just take images. We can take more sophisticated measurements like spectra and other things. But images, I think, are just an easy way to give you an example to highlight what happens. So through the course of the night, this telescope takes images of the sky. It's stored the information, the images are stored at the telescope. And then in the morning, the people who've been working at the telescope overseeing the images transmit them to a supercomputing center or a university for us to analyze. So I get in the morning and there's a set of images for me to look at. And I might be interested in answering a particular question. I won't tell you what questions I do answer because they can be quite complicated. But say, for instance, I want to know how many red stars there are in the sky. So I look through the images and I count red stars. Or maybe I want to know if stars in this direction are blue and stars in this direction are green. And so again, I could answer that by looking at the images. Going through the images one by one, me personally by eye, that's going to be way too much work. It's just so much data to sift through. So I'm going to need an automated process to go through it all. And then eventually, if I've counted all the stars and I plot, the color of the stars and their direction, and I might learn something about the way the world works, the way the universe works. Now, it's worth pointing out that until relatively recently, maybe 20 years ago or so, this wasn't necessarily how astronomers would operate. And there are still subfields of astronomy where people don't rely on some automated telescope up on some mountaintop. There are still astronomers who go to a telescope, point at exactly what they're interested in, take a picture of the sky, come back, look through that picture, perhaps by eye, or go through all of the stars one by one, and then work out the information they're interested in, the plot of color or whatever it is. So it's something of a new change that we automate this process in cosmology. When I was in grad school, again, about 20 years ago, it was much more common for individual astronomers to go to telescopes and do their own observing. So how is this related to the 5 Wyoming domains of computer science? Well, domain 1, computing systems. This is to do with devices, hardware, the software to control them, troubleshooting those devices. Well, the telescope my collaboration uses, it's automated. It's a pretty sophisticated piece of kit. It has to, for instance, know how the Earth is rotating, and it has to keep the telescope moving the other way so we're looking at the same location in the sky. We say to it, if the weather's bad, you're going to have to shut off. That's dangerous. You could get rain inside the telescope or worse, snow. If the weather's good but not great, maybe you want to look at this thing. But if the weather's great, oh, look at this thing. So it's making sophisticated decisions. And even though there are people there who can oversee the telescope, for the most part it's working by itself. So this is to do with computing systems and devices. My telescope is a carefully controlled device that will carry out the project we want it to. Domain number 2, networks and the internet. Well, I told you our data is stored at the telescope, and then it gets transmitted out to universities or supercomputing systems. And we want that data to be sent efficiently, but also lots of people are going to be interested in our data, and we're going to share it with them, of course, but maybe initially we're going to want to look at it, we're going to check for glitches, we're going to extract the main signs we're interested in doing out of it. So we want to transfer the data, transmit the data securely as well as efficiently. And this is to do with Wyoming domain number 2, networks and the internet. Send things in an organized way and also make sure it's secure. Domain number 3, data analysis. Well, I mentioned we store the data both at the university when it arrives and at the telescope initially. So when the data arrives, we have to know what's the best way of storing it. We have images of the sky that came at a certain time. Do we want every pixel to correspond to a number? Do we want time to be another number? How are we going to put this in some database we can all use together? And then, of course, once we've got the database, when we sort of start to analyze the images and start to say things like, well, which of these things in the image are stars and which of them are galaxies and what are their colors? And we're going to need processors, models to be able to essentially say a galaxy looks like this, a star looks like this. So this is to do with data analysis, Wyoming domain number 3. Now, it could be that it's very few images and it's just me looking at them and that's fine. But for the most part, we're talking now about millions of images, billions of pixels. And you need really sophisticated algorithms to be able to say, well, okay, here is a circle of pixels in the sky that looks like a star. Here, this looks like a galaxy. And so you need actually to have some pretty sophisticated algorithms to go through all this information. This is Wyoming domain number 4, algorithms and programming. And then finally, I told you that there are still some astronomers that go to the telescope themselves. Or if you go back 20 years, this way of operating, big project remotely at a telescope, wouldn't happen. What has allowed us to operate in the mode where huge amounts of data are taken remotely at telescopes, get sent across to universities, supercomputing centers, and then analyzed with algorithms. What's enabled us to do that is the whole sort of progress of the framework of computation and information technology over the last 20 years. So although, as I mentioned, there are still astronomers that go by themselves to telescopes and do their own little projects, there's certainly in my field a move towards huge collaborations of people who are doing one big project that would be super expensive if one person did it. And we're collecting vast amounts of data from a telescope that we've basically taken over to do that project. So for me, that is a huge shift in culture. I have lived through in the last 20 years the impacts of computing on the culture of how we conduct projects in astronomy. So those are the Wyoming computing domains, the 5 ones, and how, just using an example from my own personal field of work, they've affected and influenced everything that I do.